In this video, we will learn about angles in circles, angles on circles, and angles outside of circles. And here's some pictures of what we mean by that: an angle in a circle, on a circle, and outside a circle. We'll explore the relationships between angles and arcs, and we'll also define some vocab, including arc, chord, secant, tangent, central angle, inscribed, and circumscribed angle. So we're going to start by looking at some of these definitions. And so on the screen right now, you are looking at 3 examples of an arc. So these highlighted sections are arcs, and these are not arcs. So by looking at these examples and non-examples, what is an arc? So write a definition in your own words, and you don't need to Google the definition. But using just these pictures, what do you think an arc is? So one definition of an arc is it's the part of a circle lying between 2 points on the circle. So 2 points on the circle, it's that part of it lying between those 2 points. Or another definition is it's part of a circle's circumference. So the circumference is all the way around the circle. An arc is just part of that circumference. Another word that we'll need to know is central angle. So here are some examples of central angles. And here are some pictures that are not central angles. And so again, looking at these pictures, write a definition in your own words of what is a central angle. So one formal definition of a central angle is an angle whose vertex is in the center of the circle. So the vertex of the angle, or sort of the corner of the angle, is at the center. Another definition is an angle formed by 2 radii. So if you notice in all of these central angles, this is a radius and this is another radius. So a central angle is an angle formed by 2 radii. So now we're looking at another central angle, this angle here at B. And we can also see an arc between the letters C and A. So we say that this central angle intercepts arc AC. So we would say that angle B intercepts arc AC or CA. So this word intercepts here just means that this arc is sort of bounded by this angle. It's between those 2 endpoints on the circle. And on the screen, we can also see the measure of this angle, that it's 60 degrees. And just like we can measure angles in degrees, we can also measure arcs in degrees. And so this arc is also 60 degrees. And then when I move around points A and C, so if I click on one of these, I can change the size of the angle, which also changes the size of the arc. So what do you notice is the relationship between the measure of the central angle and the measure of its intercepted arc? So every central angle is equal to the measure of its intercepted arc. So no matter where we move points A and C, the measure of the angle is equal to the measure of its intercepted arc. We're now going to define another word, and that word is chord. So here are some examples of line segments that are chords. And these are not chords. And so looking at these examples and non-examples, write your own definition of a chord. A formal definition of a chord is a line segment whose endpoints are on the circumference of the circle. So notice in all of these examples of chords, the endpoints of these line segments are on the circumference of the circle. Now we are looking at another angle in a circle, but notice that this angle is not a central angle. It is not in the center of the circle. This type of angle is what's called an inscribed angle. And notice that AB, this line segment, is a chord, and so is line segment BC. These are both chords. So an inscribed angle is an angle formed by two chords who share an endpoint. And so this angle that we're looking at here is 18 degrees, but if I move around any of these points, we can see that the size of the angle is changing. But all of these angles that we're looking at here are examples of inscribed angles. So we're going to figure out the relationship between the measure of this angle and the measure of its intercepted arc. And so here, we again have an inscribed angle over here at angle B, but now we're also seeing a central angle that intercepts the same arc. So notice that both of these angles are sort of bounding in the same arc. So what we learned a moment ago is that the measure of this arc is equal to the measure of the central angle. So arc AC would be 80 degrees because it's the same as the measure of the central angle. So notice that angle B is not the same as the measure of its intercepted arc. So instead of the inscribed angle being equal to the measure of its arc, how are these related? And we can look at some more examples here. So I'm going to clear that 80 off the screen. And if I move around any of these points, again, we can change the measure of the angle, but we're still looking at all inscribed angles. So again, maybe you're noticing a relationship between the measure of this central angle, which is equal to the measure of this arc. So what we're looking at right now, the measure of arc AC would be 50 degrees because it is equal to the measure of the central angle. So after looking at another example, what is the relationship between the measure of the inscribed angle and the measure of its intercepted arc? So hopefully you have noticed that the measure of the inscribed angle is half of the measure of its intercepted arc. Or another way of thinking of that is that the arc is double the measure of the angle. And so even if we look at some smaller inscribed angles, so if we move A and C closer together, that the measure of that inscribed angle is still half the measure of its intercepted arc, or half the measure of the central angle. And even as that angle gets bigger, so let's say we make the inscribed angle all the way up to 72 degrees, then notice that it is still half of the measure of this intercepted arc. Before we learn about the next type of angle that is outside a circle, we're going to define some more words. So on the screen, you are looking at 3 examples of a secant line and 3 examples of lines that are not secants. So using these pictures, write your own definition of what is a secant. A formal definition of a secant line is a line that intersects a circle at exactly 2 points. So a secant line is similar to a chord, except that the line extends beyond the circle. Now we're going to look at several examples of a tangent line. So these lines are tangents, and these are not tangents. So in your own words, what is a tangent line? A tangent line is a line that intersects a circle at exactly 1 point. So it's a line that just barely touches a circle. It touches it exactly 1 time. So the reason we need to know the words secant and tangent are so we can learn about this next type of angle, which is called a circumscribed angle. It's an angle that's outside the circle, like the one you're looking at here. And in this example, both of these line segments, so from A to B and B to C, these are both secant lines. They intersect the circle at 2 points. But if I move around points A and C, we're still looking at a circumscribed angle. Even if I move this so that A and D are really just the same point, in which case this is now a tangent line. It touches the circle exactly once. And this is still a circumscribed angle. So a circumscribed angle can be formed by either 2 secant lines, 2 tangent lines, such as this, or one secant line and one tangent line. Now we're going to explore the relationship between the measure of the circumscribed angle and the measure of its intercepted arcs. So I know this looks like a lot going on this screen, but notice that this circumscribed angle intercepts two arcs. So it intercepts this arc here from A to C, and it also intercepts this arc over here from D to E. So every circumscribed angle will have two intercepted arcs. So noticing that this arc here from D to E, this arc is equal to the measure of its central angle. So this arc should be 20 degrees. Same thing with arc AC, that it's equal to the measure of its central angle. So that arc is 100 degrees. So we're trying to figure out the relationship between the circumscribed angle and its two intercepted arcs. So maybe you're noticing some sort of relationship between the 100 and the 20, and then the 40 over here. To make this look a little bit simpler, I'm going to hide some of these lines here. And so temporarily my writing is in the wrong spot, but I'm going to hide some of these line segments so that we can focus really on just the measures of these two arcs. And so take a moment and see if you notice the relationship between the measures of these intercepted arcs and the measure of the circumscribed angle. So maybe you have noticed that the measure of the circumscribed angle is half of the difference between its two intercepted arcs. So if you calculate the difference between the 100 and 20, and then take half of that amount, then that will be equal to the measure of the circumscribed angle, which is 40 degrees. So the difference between 100 and 20 is 80, and half of 80 is 40. So a circumscribed angle is half the difference between the measure of its two intercepted arcs. In summary, we have learned that a central angle is an angle whose vertex is in the center of the circle. And the central angle is equal to the measure of the intercepted arc. An inscribed angle is an angle formed by two chords that share an endpoint, and the vertex of an inscribed angle is on the circle, it's on the circumference. And an inscribed angle is half the measure of the intercepted arc. So if the arc is 70 degrees, then the measure of the central angle is 35 degrees. It's half the measure of its arc. And lastly, a circumscribed angle is an angle formed by two tangent lines, two secant lines, or one tangent and one secant. And the vertex is outside the circle. And we just learned that a circumscribed angle is half the difference of the two intercepted arcs. And so now we have learned about angles that are in a circle, angles that are on a circle, and angles that are outside a circle.